All right, for this page, we're working on problem number 7. This is a free response from the 2001 AP test, and calculator is allowed. I have posted the scoring guidelines, which I would encourage you to look at for any AP problems we do so you can see exactly what you get points for. All right, so looks like we have an acceleration graph with respect to time. A car is traveling on a straight road with a velocity of 55 feet per second at time 0. I like to list out what they're giving me here. So I know that v of 0 is equal to 55 feet per second. I just like to have that on my paper. I'll pay more attention to it if I wrote it down. For 0 to 18 seconds, the car's acceleration is in feet per second squared. It's given in the graph above. Is the velocity of the car increasing at t equals 2? Why or why not? So anytime you're looking at is a function increasing, you check the derivative. A function is increasing if its derivative is positive. So if I want to know about the velocity, whether it's increasing at 2 seconds, I should evaluate the acceleration at 2 seconds because that's velocity's derivative. See what it comes out to. So what is a of 2? I can just pick that off of the graph. A of 2 is equal to 15, which means that a of 2 is greater than 0. So v of t is increasing at t equals 2. I don't really want to say v of 2 is increasing. That's like a singular point. But the velocity is increasing at 2 seconds because the acceleration is positive. At what time on the interval 0 to 18, other than 0, is the velocity 55 seconds? So we know 55 feet per second. So we know that that's happening at 0. And y just means, again, justify or show your work. So where else does the velocity hit 55? So to me, I kind of want to just take this in sections and see what all the different changes in velocities are. So I think that's how I'm going to tackle this one. So I know v of 0 is 55. Okay. And then now I could do a trapezoid here, but I just want to kind of make note of like all the little individual shapes, because what if there's a change at 15 and I hit 55 for some reason, or, or at 10 or at 14. So let's kind of look at this. All right. So if I go to 2, well, that's 55, and there's been an increase of, what is this area? This area is 2 times 15, so this area is 30. So add 30, you're at 85, okay? And then what's this area? This is 1/2 times a base of 4 times a height of 15. Half of 4 is 2. 2 times 15 is another 30. So v of 6 is equal to 85 plus 30. So let's see, 80 plus 30 is 110, plus 5 is 115. All right, and then, wait, did I do my math correctly on that? 115? Yeah, I think so. All right, so let's see, v of 10? That's 115 minus, what are we going to get for this little area? So this is negative 1/2 times a base of 4 times a height of 15. So that's negative 30. So this brings us right back down to 85. All right. And then what about at 14? So this has a base of 4 and a height of 15. So 4 times 15 is negative 60. So, okay, here's one. When I jumped to 14, I'm at 85 and I'm subtracting 60. So now I'm down to 25. So somewhere in here we hit 55 again. So, okay, so we need to figure out, let's see, at what other time? So I need to find the actual time. So what about at 12? So half of this is negative 30. This is negative 30. So what if back here, back here, v of 12 would have been 85 minus 30. So that gets me to 55. Okay, so there's another time where we hit 55. Okay, and then at 14, we go down another 30. So now we're at 25. And then what's v of 16? we're going to go down a little bit more, right? So this little area here is negative 1/2 times 2 times 15. So that's negative 15. So down another 15 from 55. So if I subtract 15 from that, I get 40. And then finally at V of 18, we're going to go up a little bit. Do we make it back up to 55? Let's see. This area is 1/2 times 2 times 15. So, yeah, so looks like we hit 55 again. All right, so at what time on the interval 0 to 18 other than 0 is the car at 55? So I'm getting 2 times unless I messed up on my math somewhere. Let's see. Did I mess up on my math somewhere? Because it just says at what time. So let me check this. So 85 plus 30. I guess calculator's allowed. I better double check my math here, right? So 85 plus 30 was 115. And then we subtracted 30. And then we subtracted 30 from that. And then and then I did minus 60. Wait, okay. So, no, yeah, that was okay. Right? Yeah, so we're at 55 at V of 12. And then we subtract 30 to get here to 25. Oh, so it wasn't 55. Sorry. There we go. So V of 14, to get to V of 16, I'm at V of 14. It's because I went out of order here. So 25. So V of 14 was 25. The area between 14 and 16 was minus 15. So 25 minus 15. I knew something didn't seem right there. 25 minus 15 is 10. And then if I'm at 10 and I go up, what did I say that was? 15 again? I'm back to 25. All right, so there is only one time here at 12. Okay, so y, I kind of laid out all of the different scenarios here. So this is my y. So I'm going to say at t equals 12 seconds, v of t equals 55 feet per second. Now, this kind of feels like an intermediate value theorem thing. Like, I know that because the graph, there's only one point here where 55 falls between two of the y values, right? So as I'm going through this, I could maybe I need to say by IVT. So I'm going to say, let's see, V of t is continuous on 0 to 18. And by IVT, there is one time on 0 to 18 such that V of t equals 55. I don't really know if I had to add that or not. I've done the math here to show that that's got to be the case. But I don't know, just throw it in there. We can check the scoring guidelines to see if I needed that. On the time interval 0 to 18, what is the car's absolute maximum velocity? So here's where it paid off to do all of that annoying work. In feet per second, and at what time does it occur? Justify your answer. So for part C, this is that extreme value theorem. The candidates are the endpoints. So the candidates, I kind of already did the work, but let's pretend I didn't. The candidates are endpoints. So for T, we've got 0 and 18. And then we're talking about maximum. So anytime the relative maximum occurs, so that's where the derivative, for a relative maximum, where the derivative changes from positive to negative. So acceleration changes from positive to negative at 6, and then that's the only time. So, and if I look at my little chart, 6 is where the maximum was, right? Okay, so 0, we know that's 55. 18, we already did the work and found that that was 25. And then at 6, again, we already did the work and showed that that was 115. So I'm going to allow my work from here to work for this one. So I'm going to say they want both the maximum velocity and the time. So the max velocity is 115 feet per second at t equals 6 seconds. This is by the extreme value theorem. I don't think we actually have to cite that, but again, we're showing the candidates. I think that's enough. Okay, at what times in the interval 0 to 18, if any, is the car's velocity equal to 0? Justify your answer. This definitely feels like intermediate value theorem, right? How can we show that there's going to be a 0 somewhere? It doesn't say to, it says if any. So if I'm looking through all of this, there's no point at which the velocity actually changes to negative. So if the velocity is always positive, there's no way that it can dip down to 0. So if any, it says. So there are no times such that v of t equals 0. Why v of t is greater than 0 on the interval 0 to 18. That's all that we need to say. I think I might have the scoring guidelines. Let me see. Are these the scoring guidelines? Yeah, okay, so let's take a look at this just to see what all they wanted us to do. I'm not going to do this for every single one. Sorry, this is kind of blurry. All right, so, and again, you can find these online. I just Googled 2001 AP Calculus. Okay, so for part A, it says that, let me split screen. Oh, no, wait, I can't split screen. It's in the same thing. So for part A, V prime is equal to A of 2. A of 2 is positive. Velocity is increasing. We said that. So you get 1 point for that. Answer with the reason. Part B, you get a point for saying t equals 12. And your reason, now their reason is much more concise than mine. Let me go back and look at what I wrote. So yeah, for B, I did all of this stuff here. They were saying, okay, from the integral from 0 to 12 is 0. So that means that the change in velocity between time 0 and time 12 is 0. So you're going to be at 55 again there. I still think it's okay because it just says reason. It doesn't say the specific reason. I think that this reason is okay too, to show all of the possibilities. Let's look at part C. The maximum velocity is 115 feet per second at 6. That's what we got. So you get a point for saying 6. You get a point for the 115 feet per second. Identify 6 and 18 as candidates. So see how I listed out my candidates? I had 0, 6, and 18. Or you can talk about the velocity graph, how it's increasing, decreasing, and then increasing. And ultimately, you've got to rule out 18 and come up with 6. So there's 4 points in that. Do you have to write it exactly like they did? No, but you've got to know that your answer needs to satisfy these conditions. Okay. Part D, velocity is never equal to 0. The absolute minimum is at 16, which is greater than 0. So they showed their work differently than me. But again, it just says answer with reason. So I think if your reason is mathematically correct, then you're okay. So I think we would get full points for this, even though I have some slightly different verbiage on mine. All right, that takes care of this problem. See the next video for the next page.